Hello, welcome to my channel, and it's a lovely evening to all of you. Right, a few years ago, something remarkable began happening. People started having long conversations with machines. These machines could explain scientific concepts, write essays, compose poetry, answer philosophical questions, and many users had the same reaction. It feels like the machine understands me. But tonight in this video, I want to explore together with you a question that sits at the center of modern artificial intelligence. Can a machine appear intelligent without actually understanding anything? This question is now one of the most debated issues in AI research, involving influential thinkers such as Geoffrey Hinton and Jan LeCun. To answer it, we must examine what current AI systems actually do and what they might still be missing. Now, in part one, I want to talk on what modern AI really learns. Most modern AI systems are built using machine learning, particularly deep neural networks. These networks are trained on enormous data sets containing billions of examples. Their task is simple in principle: predict the next piece of information. So in language models, for instance, the system predicts the next word in sequence. Consider this sentence. The capital of France is. After seeing millions of examples, the model learns that the word Paris frequently follows. By repeating this prediction process billions of times, the model gradually learns the statistical structure of language. It discovers patterns about grammar, meaning, and context. And remarkably, when these models grow large enough, they begin to produce responses that feel intelligent. But there is a subtle and important point. The system is not taught facts about the world. It is trained to predict patterns in text. Now, in part two, I want to focus on the statistical parrot problem. Some researchers argue that modern AI systems function essentially as statistical parrots. The idea is simple. A parrot can repeat words convincingly, but repeating language is not the same as understanding it. Similarly, large language models recombine patterns from the vast data sets on which they were trained. They produce fluent sentences because they have learned statistical relationships between words. But critics argue that these systems lack something fundamental: semantic grounding. They manipulate symbols without necessarily understanding what those symbols refer to. When a human talks about rain, the word connects to sensory experience, physical understanding, emotional associations. We have felt rained. We know it falls from clouds. We understand the causal processes behind it. An AI system, by contrast, knows rain only through its statistical relationship with other words. So this difference may be more profound than it first appears. Now, in part three, I want to emphasize on correlation is not understanding. Okay, just a minute. I want to take a sip of water. Now, a central limitation of machine learning lies in its dependence on correlation. Machine learning systems detect patterns in data, but detecting patterns is not the same as understanding causes. For instance, imagine a data set showing that umbrellas often appear when streets are wet. A machine learning system may learn a strong correlation between umbrellas and wet streets, but it might not infer the casual explanation rain causes both. Humans, even children, are remarkably good at building causal models of the world. We infer invisible mechanisms. We ask why, not just what happens next. This capacity allows us to reason about situations we have never encountered before. Many AI systems still struggle with this kind of casual reasoning. Now, in this part, I want to say why bigger models work anyway. Despite these limitations, modern AI systems perform astonishingly well. How is that possible? One explanation is scale. As neural networks become larger and training data expands, new abilities seem to emerge. Researchers call these emergent capabilities. Large models suddenly develop skills such as translation across many languages, solving complex reasoning problems, writing coherent arguments. These abilities were not explicitly programmed, they emerge from the statistical learning process. Some researchers, including Geoffrey Hinton, suggest that sufficiently large neural networks might eventually approximate many aspects of human cognition. In this view, intelligence may simply be the result of very sophisticated pattern recognition, but others remain skeptical. Now, one reason for skepticism is that many AI systems lack direct interaction with the physical world, isn't it? Human intelligence evolved in an environment where perception and action were deeply intertwined. We learn by touching objects, navigating space, interacting with other people, experiencing cause and effect. Our knowledge is grounded in experience. AI systems trained purely on text lack this grounding. They learn from descriptions of the world rather than from the world itself. This limitation may explain why AI systems sometimes produce responses that sound plausible but are factually incorrect. Without direct contact with reality, the system cannot verify its own knowledge. It can only generate the most statistically likely answer. The next one that I want to pinpoint is the opacity problem. Another challenge arises from the internal complexity of modern AI systems. Large neural networks contain billions or even trillions of parameters. These parameters interact in ways that are extremely difficult for humans to interpret. As a result, even the engineers who build these systems often cannot fully explain how they arrive at specific outputs. This phenomenon is sometimes called the black box problem. If we cannot fully understand how the system reasons, it becomes difficult to evaluate whether it truly understands anything at all. Transparency remains one of the major research challenges in AI today. Now let's talk about understanding as simulation. At this point, we arrived at a deeper philosophical question. Suppose a machine behaves exactly like a system that understands. It answers questions correctly. It produces insightful explanations. It participates in meaningful dialogue. Does it matter whether genuine understanding exists internally? Some philosophers argue that behavior is sufficient. If the system consistently behaves intelligently, that may be enough. Others argue that genuine understanding requires internal semantic representation, something more than statistical associations. This debate has echoes of earlier philosophical discussions about the nature of mind and consciousness. Artificial intelligence has revived these questions in a very practical way. So, where does this leave us? Many researchers believe the next generation of AI systems must go beyond pure statistical learning. Future systems may incorporate causal reasoning, embodied interaction, world models, multimodal perception. Researchers such as Jan LeCun have argued that AI systems must learn structural models of the physical world in order to achieve deeper forms of intelligence. This shift would move AI closer to the way biological intelligence operates. The goal would not simply be machines that generate convincing language. It would be machines that genuinely understand the structure of reality. So, as a closing of my lecture, artificial intelligence has made extraordinary progress. Machines can now perform tasks once thought to require human intelligence, yet we still do not fully understand the nature of understanding itself. It is possible that today's AI systems, just a minute. Yeah, where was I? Sorry. So I was talking about the artificial intelligence has made extraordinary progress. Machines can perform tasks once thought to require human intelligence, yet we still do not fully understand the nature of understanding itself. It is possible that today's AI systems represent a powerful but limited form of intelligence, one based on pattern recognition rather than true comprehension. Or it may be that understanding gradually emerges from sufficiently complex computation. We simply do not know yet. What is certain is that artificial intelligence has forced us to confront one of the deepest questions in science and philosophy. And what does it mean to understand? And as we continue building increasingly powerful machines, the answer may reveal much about the human mind as it does about artificial intelligence. Thank you. So this is the end of my short minute lecture, public lecture, and I see you in my next video. And God bless you bountifully in every aspect of your life. Remember, God loves you so much. Goodbye.